In this video, we're going to be looking at the product rule for differentiation. Okay, so when do we use the product rule? We use the product rule when you've got two functions multiplying each other. And it's y equals uv, where u and v are two different functions. And this is the formula you need to memorize for the product rule. dy dx equals u dv dx plus v du dx. Okay, so let's look at a situation where we're going to use the product rule. So here I've got y equals x multiplied by ex. And we can't use any other differentiation method we know up till now. So it must be the product rule. And what's the giveaway that it's a product rule? Well, you've got two functions timesing each other. You've got x, which is a function, timesing ex. Okay, so it's perfect. It's in the form uv. So what is u and what is v? And in this case, it wouldn't matter which way around you do it. But we'll say that x can be the u and v can be ex. Now, look back at the formula. We've got u, we've got v. But to fill in that formula, we need to know what dv dx is and what du dx is. So let's go ahead and do that. Now we've got all the parts we need for that formula. So we just need to go ahead and fill it in. So my u is x. My dv dx is ex. Then we have a plus. And my v is also ex. And that multiplies to du dx, which is 1. So that's just ex. And it's as simple as that. Now, a lot of people don't write out what u is and what v is. And then, of course, work out du dx and dv dx. They just get used to it. They simply say it's x times the differentiation of ex plus ex times the differentiation of x. But I'd advise you to set it out like this for at least a dozen questions, until you're very sure with what you're doing. Okay, so here, is this the product rule? Yes. We've got a function, x squared, timesing another function, ln x. Now, you could simply say it's x squared times the differentiation of ln x plus ln x times the differentiation of x squared. But you can do that later. For now, we're going to practice setting it all out. So, of course, this is in the form y equals uv. And we can say u is x squared. And v is ln x. And it wouldn't matter which way around you did it. So that's our du dx. And you should know the differentiation of ln x is 1 over x. And now we're going to simply fill in that formula. Now I hope you've already memorized that formula. Just for now, I'm going to write the formula out again. And we need to just simply fill it in. And that's our answer, but you could go ahead and factorize it as well. Okay, so let us do two more examples. Here we've got y equals x sine x. And it's the product rule again, because it's in that form uv. And it wouldn't matter what you let u be and what you let v be. Okay, so let's go ahead and differentiate. And you should know the differentiation of sine x is cos x. And all we need to do is fill in the formula. Okay, so let's go into the next example. Now, if you're not familiar with this notation, it just means simply differentiate xy squared. And yes, this will be the product rule because you've got that uv situation. So you're going to fill in that product rule formula. So we'll say u equals x and v can be y squared. So let's go ahead and differentiate them. Now, to differentiate y squared, you need to use implicit differentiation. And I'm hoping you've looked at the video on implicit differentiation. If you haven't, just go back and have a look. You simply differentiate as if it was x, so it'll be 2y, but you slap on that dy dx. Okay, so we need to go ahead and fill in the formula. I'm assuming you've memorized that formula. If you haven't, just go back in this video and just memorize it before you continue. So it's u dv dx plus v du dx. So starting with u, so let's find our u. And it's simply going to be y squared times 1. Now I've run out of space here, but if you want, you can also factorize out y to make it a little bit tidier. Okay, so now we're going to look at the quotient rule. Now the quotient rule you use when you've got two functions dividing each other, when it's in the form y equals u over v. And if it is in that form, here's the formula you need to use, and I'd advise you to memorize it. So we have dy dx equals v du dx minus u dv dx, and all of that is over v squared. And of course you can use it on y equals u over v. Now if you look at the question below, we've got y equals sine x over x, and indeed it is in that form, u over v. So u here would be sine x and v would be x. And looking at the formula, you need to differentiate these in order to fill it in, so go ahead and do that. Okay, so now we're going to fill in that formula. And we've done it. So make sure you've memorized that formula. It's quite similar to the product rule formula, except you've got over v squared and there's a minus in between them. And remember, it starts off with v. Okay, so let's try this question. Now I brought the formula down also because it's a tough formula to memorize, and I didn't expect you to do it right away, but do take the time and memorize it. Okay, so in this situation we have got u over v, so we're going to use the quotient rule. Okay, now in both cases you need to be good at the chain rule to differentiate these. So definitely go back and look at the chain rule video to make sure you're familiar. Now this one stays as e2x. It also times it by the differentiation of 2x, which is 2. And that's simply the chain rule. And in this one, the 2 comes to the front. And the power goes down by 1. So now it becomes power 1, which I don't need to write down. And you also times it by the differentiation of what's in the brackets, which is x plus 2. However, the differentiation of that is 1. So it's not going to make any difference in this case. And now we can just fill in that formula. And we can go ahead and simplify this a little bit more. And I'll leave it just there. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.